state Newton's universal law of gravitation. You can do that, right? Gravitational attraction between two mass points, okay, is proportional to the product of their masses and inversely proportional to the square of their separation. And the equation F equals G m1 m2 over r squared. Satellite mass m orbits the planet of mass big M. Derive the following relationship between the period of the satellite and the radius of its orbit. We need to find the equation for the period, so we need to think period, how to find the period. Period is distance divided by speed, okay? And distance for one orbit is 2 pi times the radius of a circle, okay?
Yep.
Divided by the speed that it's orbiting around the planet. So the next thing we need to find the speed, and we will find that by using the gravitational force F equal G m over r. Mass planet big M, mass of satellite, radius, actually distance from the distance r from the satellite to the planet center equal to centrifugal force m v square over r. Okay,
yep.
This is centrifugal force. So this step, writing this equation, is very common for this topic. So from this equation, we get v squared equal gm over, this is r squared, r, okay?
Yep.
From the first equation here, if we square the two sides to get like a similar form with this equation, t squared will be equal to square the whole thing here, okay, which is 4 pi square r square over v square, okay?
Yep.
And then put the v square here into the last equation, 4 pi square r square over gm over r, okay? Therefore we have 4 pi r bottom, bring it top, okay? Keep over gm, done, okay?
Yep.
This equations the relationship between the square period t square and the cube of distance r is called the Kepler third law. Okay, Kepler third law. Question C. A polar orbiting satellite has an orbit which passes above both of the Earth poles. They passes over the north and the south pole. The polar satellite, okay, this period 6 times 10 to 3 seconds, meaning 6,000 seconds, which means how many minutes? 6,000 divided by 60 minutes, 60 seconds for 1 minute. So it takes 100 minutes, okay, approximately equal to the period of the Starlink satellite, okay. This is the mass of the Earth and the radius of the Earth. U duration show that the average height above U plus 1. The height above the surface of the Earth obviously like 800 kilometers. So it is also clear how to do that, right? Using this relationship. So plug the numbers here into this equation, calculate r cube, calculate r, and then subtract the radius of the Earth. You will get the height of the satellite. Okay.
Yep.
The period is 6,000 seconds. 6 times 10 to 3 squared equal to 4 pi square times r cube. We didn't need to find this one. Divided by g 6.67 times 10 to negative 11 times the mass of the Earth, which is given up here 5.97 times 10 to 24. So please use the calculator and find this r, and then you subtract this r from the radius of the Earth, which is 6.37 times 10 to 6 meter. You get the height of the satellite. You see the radius. This is exactly the value that I expected. 71342 238 minus 6, 370000. Okay, yeah, about 764 kilometers from the surface of the Earth. Okay, 764 kilometers away from the Earth, which is approximately equal to 800, which they ask us to prove about. Okay, and if we round this thing to one significant figure, it will be 800.